Hello everybody, welcome to linuxn.com YouTube channel. In today's video, we're gonna discuss 7 most important data structure related questions that could be asked in any of your interview. Okay, so these are the sort of general questions. We would talk about specifically about linked lists as well. All right, so without a further ado, let's start. So first question. That is a very general question, and obviously the interview is about data structure, so you could be asked directly that what do you think what data structure is? So the answer to that question is that a data structure is a way of organizing the data so that the data can be used efficiently. Okay, so there are sort of different kinds of data structures that are suited to different kind of applications. Okay, so some of those applications would be highly specialized to some, highly specialized tasks, and the other would be like, sort of generalized. Yeah, that is the definition of data structure. And that would be sufficient. Okay, sufficient explanation. So I repeat that the data structure is basically a way of organizing the data, okay, so that it could result into the efficient usage of this data. Okay, so that is just a simple answer. So now let's move on to the next question, and that is question number 2. What are linear and non-linear data structures? So if you talk about the linear data structure, these are the kind of data structure which has elements from a sequence or a linear list. Okay, so example of that would be arrays, linked lists, stacks, and queues. Okay, so we'll discuss stacks and queues in this video as well, and we'd also discuss linked list as well. So if you talk about the nonlinear data structure, then these are the data structures that are nonlinear if traversal nodes they are like in a non-linear in nature. They don't have a specific sequence. So the example of that would be graphs and trees. Okay, obviously they are not in the sequence. You can access any node anytime you want. But if you talk about arrays, stacks, and queues or linked list, you have to move in an orderly way or in a sequential way to get to a point, right? But in graphs and trees, there is no such thing. So I repeat that the linear data structure is a sort of a sequential related. They are linear, and non-linear, they are not like sequential. Okay, so that is a simple difference. So let's move on to what is a linked list and what are its. So if you talk about linked list, a linked list is a linear data structure. It's similar to arrays, where each element is a separate object. Okay, so element, when I say element or object, it means that I'm talking about the node, okay, the specific node in the linked list. So the node, it basically comprises of 2 items, the data and a reference to the next node. Okay, so each linked list have like the data which is stored in it and the reference, the address of the next node. Okay, that is also stored in the current node. All right, in the linked list. So there are basically 3 types of the linked list. If you talk about the types of the linked list, the number 1 type is singly linked list. So let me just write here. Number 1 type is singly linked list. Okay, so if you talk about the singly linked list, it is a type of linked list where every node stores address or reference of the next node in list, and the last node has next address or reference as null. Okay, so every node is going to have the address of the next one, but the last node would have, a null reference or a null address. Okay, so the next type is basically, let me just write down here, doubly linked list. Okay, so if you talk about the doubly linked list, it is a kind of a linked list where you have 2 references associated with each node, 1 reference point of the next node and 1 of the previous node. Okay, so in it, for the last one, for the last linked list, the address would be null, and the previous address of the first linked list would be null as well. Okay, so if we let me just write here an example. So let's say this is null, and what would happen is that this would be the address 1, let's say, and then we would have the address 2. Okay, and obviously at, let's say, if you're talking about the next address of the final, which is ADDR2, that would be, I think, let me just write down here, that would be null as well. Okay, so that would be kind of the structure of the doubly linked list, okay, in which we would have the address of the previous node and the next node as well. Okay, both addresses or both references. So the next type, the third and the last type of the linked list, is the circular linked list. Okay, so if you talk about the circular linked list, it is a kind of a linked list in which you have all nodes and all of them are connected to form a circle. Okay, so like the last node in the previously types of linked list, like doubly linked list and singly linked list, they were not attached from the last and the first. Okay, in this case, in the circular linked list case, they all of them are connected, which means that the last node is going to have the address of the first node as its as its next node. Okay, so the next pointer of the last one of the last linked list is going to be the first one. So that kind of make a form of a circle, okay, a circular shape. And there is no null at the end of this because it is going to have the address or the reference of the first one. So a circular linked list, it can be a singly circular linked list or doubly circular linked list, which means that it could be like, if it is a singly circular linked list, it means that the last linked list element is going to have the address of the first element and first is going to have the address of the second element. Okay, but if it is a doubly linked list, which means that you also have to store the address or the reference of the previous linked list, then in that case it's gonna be like the first linked list, it is going to have the address of the last linked list element as a previous element, and the last element is going to have the address or reference of the first element as its next element. Okay, so I hope you have got the point. These things are very simple. They are not complicated once you understand them. Okay, so I remember that I have studied these things like years ago, but I just have to read it and I am good. All of them, they're very simple and very easy to understand once you understand. Okay, so now let's move on to the next question, question number 4, which is write a function to reverse a linked list. Okay, so the idea is that this single question would cover the insertion of the linked list as well, and then the reversing of the linked list as well. So basically in this single question we are answering 2 questions. Okay, so if someone asks you that how to insert an element in the linked list, you can also do that by just following the code that I'm gonna do in C language, and you can basically skip the reverse part and you can just write down the insertion part in the linked list and you would be good. Okay, so without a further ado, let's go ahead and let's write a code to reverse the linked list. Okay, so we are gonna do that in C. So what I'm gonna do is that I'm gonna open up my terminal. I'm gonna go to my desktop where I have my C file, I guess. So if I ls here, you can see that I have this demo.c. So what I'm gonna do is that I'm just gonna clear it and I'm gonna open that up. So I'm gonna open that in my gedit editor. So I would write here the file name, I hit enter, and you can see that this is my C program. Okay, so previously we have done C string video, C interview string questions. So that is basically code of that. So let's just remove it. So what we are gonna do is that we are going to have here two libraries or two header files that we're going to need. One, we already have it, stdio.h. The second one that we're going to need is, it's going to be stdlib. Okay, so we'd write here include, and then we'd write here stdlib.h. Okay, so this is the second header file that we need. So the next thing that we need to do is that we have to create a structure. So let me define, let me explain to you that what we are gonna do in this code. Okay, so the idea is that first of all, we are going to initialize pointers. Okay, so these pointers are gonna be like for the current, current pointer is going to have to point to the current linked list. The previous pointer is going to point out to the previous linked list, and the next pointer is going to point out to the next linked list. Okay, so what we're going to do is that we're going to run a loop through the linked list. Okay, and in the loop, inside the loop, before changing the next of the current, okay, of the current pointer, what we do is that we store the next node. Okay, and then we change the next of the current node. Okay, so I can feel it that it is a little bit complicated, but when we will basically do it, that would be quite easy. So let's say, for the sake of understanding, if I'm just writing here, let's say this is the previous node. Okay, and here we have the current node, and here we have the next node. Okay, so the idea is that first of all, during the iteration, what we are going to do is that before changing the next of the current, okay, we are going to store the next node. Okay, so what we are going to do, let's say this is the nxt variable, and we are going to store the current, okay, of the next. Okay, so that's what we're gonna do. So in short, what we are gonna do is that we are going to move from the previous linked list, or from the current linked list to the next linked list. Okay, so for that we have to do it. So when we'll basically code it, you will understand it in a better way. So without a further ado, let's keep on doing the code. All right, so first of all, we are going to create a node. So for that, we have structures in C. So the code is going to be a little bit complicated if you're not familiar with C, or if you're not familiar with programming at all. So I recommend you get, obviously if you're watching this interview question of data structures, you know something about data structures, that's why you're here. Okay, so I'm assuming that you know something good about programming as well. You have good sense of programming. So we have structure node here. So now what we're going to do is that first of all, we're going to have here the integer data type, and then we're going to have a variable which we would call d, okay, or data, and then we're going to have here the structure, and then obviously we're going to have here node static nxt. Okay, so it is like next. So now what we're going to do is that we are going to write a function to reverse the linked list. Okay, so for that we would have a static function. So what we would do, would write here static, and then we'd write here void, and then we would write here rev linked list. Okay, so because we are going to reverse it, and we are going to write here inside of that struct, and then we're going to write here node static. This is a pointer as well, and then obviously we're going to have here a reference. Okay, so ref is the reference variable, and now inside the function we are going to create the body of the function, and inside this function what we're going to do is that we are going to work on this node, the node specifically that we have created. So what we would do, would write here struct node static. So we are going to create other nodes. So that would be, let's say, previous, and we're going to store null here. And then we have the current node. So we are going to create that as well. Node static, and that's going to be current. And we're going to put here the equal sign. And here we are not going to have null. Rather, we are going to point to the reference that we have. So what we would do would just simply write here static, and then would write here reference. Okay, so the variable that we have defined as an argument inside the reverse linked list method or the function. Okay, so now we'd basically create the next node, and guess what, that node would be empty as well for now. So we'll just write here node static nxt equals, and that would be null as well. Okay, so now what we're going to do is that we're going to run a loop, and we are going to do that we were discussing before. Okay, so we are going to have here a while loop. Okay, and inside this while loop, what I'm going to do that I'm going to put a condition, and that condition would be that until and unless the current is not equal to null. Okay, the CUR is not equal to null. Okay, right now it has the reference address, and until and unless it is not null, what we need to do is that we need to store next. Okay, so for that, what we would do would have the body of the while loop, and inside this body of the while loop we're going to perform this thing. Okay, so we'd write here nxt next, and then we'd write here, let me just write here current, and then we're gonna point towards the nxt as well. Okay, and after that, what we are gonna do is that we are going to reverse the current node's pointer. Okay, so how do we do that? Would basically point towards previous. Okay, so for that, what we would do would just write here current, and then we'd write here nxt, and then we'd put it equal to previous. Okay, so that's how you basically reverse it. Okay, that was fairly simple if you're understanding these things, because the magic is happening right here in these two lines. Okay, so you can see that first we had the next pointer that we are storing, and then we are basically directing it towards the previous. Okay, which means that we are trying to reverse it. So now what we're going to do is that we are going to move the pointers to one position ahead. Okay, or one step ahead, you can say. So how do we do that? What we would do would just come here and would write here previous. Okay, would put it equal to the current one. All right, and the next thing we are going to do is that we are going to put the current one is equal to next one. Okay, so yeah, that's pretty much it. So here we end our loop, and the next thing that we're going to do is that we are going to give the current reference, we are going to give it to the previous node. Okay, that would be helpful in reversing as well. So we just simply write here ref, and we put it equal to previous. All right, so I hope you have got the point. That was fairly simple. There was no difficulty in it. So now what we're going to do is that we are going to create a function in which we would just simply push the data into the linked list. Okay, so that's related to the insertion in the linked list as well, you can say. Okay, so basically it is related to pushing a node in the linked list, you can say. Okay, so what we would do would just simply write here void function. So we just write here void, and then we'd write here push, and what we do, we have here the structure, and we'd have here node static, and then obviously we'd have here two argument. One would be the reference, and the other one would be the integer number that we are going to push. So we'll just write here integer d. Okay, so we have d here as well, so let's just write here new data. So let's just write here nd, and now what we're going to do is that inside the body of the push function, we're going to write a simple code. Okay, So what we would do, would just write here struct, and then we just write here node static, and then we're gonna write here new node. We just write here a new node, okay, and then we're just gonna put it equals to, and we are going to use the MALLOC or memory allocation function. If you don't know what that is, we have discussed it in the C interview question. So what I'm going to do is that I'm going to put the link in the description to that video as well, so that you can go ahead and you can watch that. So we'll just write here struct, okay. If you don't know what that method is, what that function is, we have explained that in detail in the C interview question. That is a 1-hour video, and we have done pretty good question explanation there, okay. So you can go and check it out as well. So we just write here size of, and then we'd write here struct node, okay, and that is pretty much it. So we put a semicolon here, and then we come to the next line. The semicolon is not supposed to come to the next line, by the way. So now what we do that here, we are going to use this new node that we have created. So we write here new node, and then we use the data variable that we have created above, which is like here, okay. And what we are gonna do now is that we're gonna put it equal to the new data variable that we have created, and we're passing it as an argument, okay. And the next thing that we're gonna do is that we're gonna write here new node, and we are going to put it equal, we're going to point it towards the next, okay. And then obviously inside here we're going to use the reference, which is going to be static ref, okay. So now we put a semicolon here, and we are almost done. But the one thing that we need to do is that we need to point it towards the new node as well, okay. So for that, what we would do would just simply write here static ref, and then we put it equal to new node. All right, so I hope you've got the point. That was really simple. So that's how you basically push it, okay. So now what we can do is that we can either write a code in the main function, in the main block, or what we can do is that we can simply just write a function for specifically focused or devoted for the printing of the linked list, okay, so that we are able to see if the reverse function is working or not. How would we know that if reverse function is working or not? First of all, we have to create a linked list, okay. We need to push the nodes, and then obviously we need to see the output if that linked list is reversed or not, right? So that is the way to know. So for that we need a print function, right? So the print function that would specifically print out the linked list. So what we would do would have here a void function actually outside of it. So would have here void, and then we would have here print. Let me just write here. P linked list, which will print linked list, okay. So let me just write here print linked list. So inside of here we are not so we would create a print linked list function, P linked list you can say, and here what we're going to do is that we're going to have a structure as the argument, node static, and we're going to have here reference as the argument as well, okay. So now what we're going to do is that we're going to have here the brackets, and inside these brackets what we're going to do is that we're going to create a temporary variable, okay. So we'll just write here node static, and this is going to be a temporary variable, so let's call it TMP. And now what you're going to do is that you're going to put it equal to the reference, okay. And once you put it equal to the reference, now you are going to have a while loop, because the printing of the linked list is going to be like, it could be huge as well, right? So it could be more elements or more nodes. So we have to use for loop here. That is obvious. So the condition would be that until and unless the temporary variable is not equal to, let me just give a space so that it is more clear, until and unless it is not equal to null, you need to keep on working. Okay, so I'm talking to the loop. All right, so we just have here brackets, and inside these brackets I'm gonna have some code. So what I'm gonna do is that I'm gonna have here a printf statement. Obviously we need to print it. So what we're gonna do is that we're gonna have here a %d sign, and obviously we can have here comma or semicolon or whatever we want, and then we're gonna have, or we can just have a space here as well, it doesn't really matter. And then what we can do is that we're gonna have here a comma, and then the temporary variable is going to point towards the data that we have, okay, inside the d variable. And the final thing inside the for loop, or inside the while loop, excuse me, we are going to point this towards the next variable, or the next pointer, you can say. Okay, so we just write here next. So yeah, that's it from the print linked list function. So now what we're going to do is that we're going to have a final block of the code, which is obviously the main block. So if we have written these three functions, so if we don't have the main function, there is no reason that we are going to get the output. Okay, so you have to have the main block, which is really crucial. So we just write here integer main, and we're gonna have here the code inside here in the main block. So first of all, what we're going to do is that we are going to start with the empty node, or the empty linked list. Okay, so first of all, we have an empty linked list, right? So we're just going to write here node steric, and then we're going to write here, let's call it reference. Okay, the first reference, you can say, and then we're going to put it equal to null. Okay, so we put it equal to null, we put a semicolon here, and now what we're going to do is that we are going to push the values to the reference. Okay, we can push as many values as we want. So let's say we push 5 values. So let's say we just write here push, and then we use the reference ampersand sign ref, and then we put a comma here, and then we basically push any integer value. So let's say we push 100. Okay, so now what we're going to do, put a semicolon, and we just copy paste it. Okay, so we paste it like 4 times more because we want to push 5 nodes here, right? So we just copy paste it, like this is the 3rd time, and this would be 4th time, and this would be 5th time. Okay, so here we go. Let me just change the values. So let's say it's 300, it's 200, it's 600, and it's 800 or 900. Okay, so these are the 5 nodes that we have pushed. So now what we would do, that we are going to reverse it using the reverse function. Okay, so first of all, what we're going to do is that we are going to print out the, let's write here printf, and we're going to write here like, let's say we write here before reversing. Okay, and then we are just simply going to print it out, okay, using the print function. And what we would do would just simply write here print function, which is p linked list. Let me just look at it. Yes, that is the name of the function. I think p is in the capital, so make sure it's actually case sensitive, so make sure that you properly call the function. Okay, so we call the function here, and now what we're going to do is that we're going to print it. So for that, we just pass the reference through it. Okay, so we pass the reference through it, and now what we're going to do is that we're going to reverse this linked list. Okay, so for that we have a reverse function, which is I think the name of that would be this one. Okay, so let me just copy it so that we don't make any spell mistakes. All right, So remember that C is case sensitive. Okay, so now for reversing it, what we're gonna do is that we're gonna pass the address of that reference through it. So what we do, we just write here ampersand and then we write here reference. Okay, so after doing it, what we're gonna do is that we are going to reverse it. So obviously after calling that function, it would be reversed. So we'd say here after reversing. Okay, so now we basically go ahead, put a semicolon here, and then what we're gonna do is that we are going to write here print the function, obviously, which is print linked list. Okay, so we basically call that function, we basically pass through that our reference, and after that, that is it. So we just basically return 0 here. Okay, so I hope you have got the point. I have explained the code you know, line by line along with it, okay, when we were basically coding it. So I don't think that we need to explain it again. So the code is here. You can just watch the video to write the code, because I can basically copy this code and give it to you directly, but that would be actually of no use. Okay, so if you check your code again, we need to put it in all capital. That was a mistake. So just double check your code always. Okay, so we just save it and we go to our terminal to run this code. So what we're gonna do is that we have to cross this so that we can actually see this thing here. So now we'll clear it and we try to run our code. Okay, so in order to run your code, you have to write a line something like this in C, gcc demo.c, which is the file name. -O is the flag, and the output is going to be the output binary file that is going to be created. And when you would run this output binary file, then you'd be able to see the output. Okay, so here we basically compile the code, and you can see that there are no errors here. So what we can do is that now we can run our output file, the binary file, you can say. We run it and you can see that it says before reversing it was 900, 600, 200, 300, 100, and after reversing it's almost the opposite, which is 100, 300, 200, 600 and 900. So one more thing that we could do is that we can actually edit it. So what we can do is that we can open it up and we can have here inside the print function, we can have like /n here, okay, for each node, and we just save it and we come here so that we basically print that out separately. Okay, so what we're gonna do is that we're going to run our code. We're going to run our output file, and you can see that before reversing, the first node was 900, 600, 200, 300 and 100, and after reversing, the last node is 900 and the first node is 100. Okay, so we have successfully written a function to reverse the linked list as well. Okay, so now let's move on to the next question, which is question number 5. How is an array different from a linked list? Okay, so the idea is that if we talk about arrays, the size of the arrays is fixed and the linked list size is never fixed. Okay, so we can actually write it down here as well. So we can write here size of array fixed, okay, and size of linked list not fixed. All right, so let me just keep it like a little bit smaller. So what we're gonna do is that we're gonna decrease the size of it, maybe till, let's say, 20. Okay, so the size of array is fixed and the size of linked list is not fixed. Okay, so now what we're going to do is that we're going to write here the next difference. That would be that insertion and deletion in array, if you talk about elements, if you want to insert or if you want to delete an element, it is very expensive. Okay, so if you talk about, you know, the linked list, that is very easy and very simple. Okay, so you can say that let me just write here, insertion and deletion in array is difficult, okay, in comparison to linked list. Okay, it's not like that it's difficult. In comparison to linked list, it's difficult, while insertion and deletion in linked list is easy. Okay, so the third difference would be that you can access anything in array randomly. So for example, if you want to access, if the array has 10 elements and if you want to access the element on the 7th index, you can do that. But in the linked list, you cannot do that. You have to go through a specific node. Okay, you have to access the first node, the second one, third one, and the fourth one, and then the fifth one. Okay, so you go in a sequence, while in array you can just, you know, pinpoint any of the index and directly pick it up. Okay, so we can have here random access in arrays is allowed, while in linked list it's not allowed. Okay, and if you talk about the extra memory space for a pointer, that is required with each element of the linked list. Okay, while in arrays you have an index and you don't need any extra memory space for that, while in linked list you need that. Okay, so you can write here the index, we can call it as reference as well. So we can say reference doesn't need memory, and we can say reference needs memory. Okay, so doesn't need memory in arrays. Let me just write it down here as well, and here in linked list. Okay, so last but not the least, that arrays have a better cache locality that can make a pretty big difference in performance, while basically linked list doesn't have such things. So you can say that arrays are better in terms of performance. Obviously linked list has its own significance, but in terms of performance, if you say, arrays are better. Okay, so that these were like the differences between arrays and linked list. I hope you have got the point. So there are multiple functions. In total, you can say 5 that we're going to discuss here. So let me just write them down here for you. So let me just basically make this smaller. So the first function or the first operation that can be performed on the data structure, that is really important, and that is basically insertion. So if you talk about inserting anything, then adding a new data item in the given collection of data items, that is basically insertion. And if you talk about the deletion, it is deleting an existing data item from the given collection of data items. That is basically deletion. So entering is insertion, removing is deletion. So that was fairly simple. So the next thing is basically sorting. Okay, so the idea is that if you talk about sorting, that if you arrange the data items in some order, doesn't matter what the order is, the order could be anything like ascending or descending order, or in case of numerical data, if you're talking about, then ascending and descending is one form of sorting. And then you can have any sort of sorting as well. So for example, if you are sorting by the numbers which are like divided on 2, so things like that, you can have any sort of sorting. Okay, so the most famous ones are the ascending and descending order sorting. Okay, so the second last one actually, that would be, let's say, searching. Okay, so the idea is that if you talk about searching, as the name represents, find out the location of the data item, if it exists in the given collection of data items or not. Okay, so finding the location of the data item in a specific collection is called as searching. That was fairly simple. And then the last but not the least is traversal. Okay, so let me just write here traversal. So the idea is that traversal approach, it is known as accessing each data item exactly once so that it can be processed. Okay, so you just have to access the data item once, not more than once, and it would do the job. Okay, so these are the 5 popular operations that you can perform on data structures, and we have answered the question successfully. Okay, so last question but not the least, which is difference between stack and queue. So if we talk about that, then the stack and queue both are the non-primitive data structures. Okay, so the main difference between stack and queue are that stack uses LIFO, which is last in first out method, to access and add data elements, while if you talk about queue, it uses first in and first out method, which is also known as FIFO. Okay, so stack has only one end open for pushing and popping the data elements. On the other hand, if you talk about queue, it has both ends open for enqueuing and dequeuing the data elements. Okay, so stack and queue are the data structures used for storing data elements, and they are actually based on some real world equivalent examples. Okay, so what we can do is that just write here stack. If we talk about stack, it is first in and first out. Okay, so it also, you can call it FIFO. And if you talk about it is last in and first out. Okay, first in first out is for queue. So let me just write here queue. So first in first out FIFO, and the stack is, let me just write here, last in and last out. Okay, you can also call it as LIFO. So yeah, if you talk about FIFO, first in first out, it means that let's say this is a queue. Let me just write here number from 1 2 3 4 5. Okay, so let's say that you have inserted 5 as the first element, 4 is the second one, 3rd is the third one, and 2 is the fourth one, and 1 is the last one or the 5th one. Okay, so let's say you have entered in this order from 5 to 1 in the queue. So now what's going to happen, that the first element is going to be out the first. Okay, so for example, you need to access 3. Okay, so first of all, what you're going to do is that you're going to access 5, then you're going to access 4, and then you would be able to access 3, because first in first out. Okay, so first 5 would be out, then 4 would be out, and then 3 would be out. Okay, so that is basically the concept of queue. All right, while if you talk about stack, and let's say we have 1 2 3 4 5, then let's say you again need to access 3. So what would happen, that it's last in and first out, actually. Yes, last in and first out. Okay, I was mistaken here. So the idea is that in this case, let's say that we have inserted in the same order. Let's say we have inserted 5, then 4, then 3, then 2, and then 1. So now what would happen if you want to access 3? Now in this case, what would happen, that first the last element would be out first. So for example, if you need to access 3, first you would access 1, then you would access 2, and then you would access 3, which you need to access. Okay, so it means that last in first out, the last element that you would enter, it would be accessed first. Okay, so that means that last element 1, that would be out first, then 2 would be out, and then 3 would be out, and you would be able to access 3. So I hope you have got the point. That was the difference, the main difference between stack and queue. Okay, the working principle and about the structure. Okay, so there are other differences as well, like operations performed, push and pop that they perform and how they perform it. The main summary that I have given you here, that is sufficient, and now you understand the basic and the main and the most profound thing which is different between stack and queue. Okay, so I hope you have enjoyed this video, you have learned something new. So that's it from this video. I hope you have enjoyed it, you have learned something new. If you have any questions, ask them in the comments below. If you have liked the video, give it a thumbs up and share it with your friends. And for written articles, you can always visit our website linuxin.com. And in the end, thank you so much for watching.